Good morning, everybody. This is Divyavani, working as assistant professor in CSC department in Institute of Aeronautical and Engineering College. So, in the last sessions, we have discussed about the deterministic finite automata, and in these classes, we are going to discuss some more examples, or we can call them as a complex examples on this deterministic finite automata. Right? So the first example that I'm taking here is construct a DFA that starts with 0 and ends with 1 and on the input symbols 0 and 1. So whenever if I see the question, first of all I have to identify what are the symbols that I have given. So what are the symbols that I have given on the question? That is a sigma is equals to 0 and 1. 0 and 1 are the input symbols that they have given. The next, what the question they have asked, we have to read it once again. Construct the DFA that starts with 0 and ends with 1. So based on the question, we have to write the language. Here language is we have to write all the strings that starts with 0 and ends with 1. So what is the minimum string that will be contains in the language is 0, 1. Right? 0, 0, 1 and 0, 1, 1. That means any length string it might be, that it should starts with 0 and ends with 1. So on. I can get any length of the string, right? So based on this language, the first step input symbol, second language. And the third one is based on the language, we need to draw the finite automata or a deterministic finite automata. So how the finite automata or deterministic finite automata should be means, it should accept all the strings which are present in the language, and at the same time it also should reject the strings which are not present in the language. So that type of a deterministic finite automata we have to be construct here. Right? So first, as I have told you previously, first we need to check whether the language is a finite language or infinite language. So if the language is finite language, we should take the maximum length string to construct the DFA. If the language is infinite language, we should take the minimum length string to construct the DFA. So first, this language is a infinite language, right? So that is the reason why I am taking the minimum length string. So what is the minimum length string here? 0 and 1. So based on that, by using 0 and 1, I need to reach the initial state to the final state. Right? So that particular structure we call it as a structure of the basic structure of the DFA. So what is the basic structure? Starting with the initial state, on seeing 0 and 1, I reaches the final state. So this is my basic structure. So and I am giving the names here Q0, Q1 and Q2. So now is this a DFA? No, this is not a DFA. Then how the DFA should be considered? That means in DFA every state should contains all the input symbol transitions at least exactly once. So here Q0 contains a 0 transitions, 1, so 0 transition, but it does not contains a 1 transitions. At the same time Q1 is having a transition for the 1, but it does not contains a transition for 0. And Q2 also it doesn't contains 0 transitions as well as a 1 transitions. So as my question is, it should start with the 1 and ends with the 1. So after 0, in between I can get any number of 0, but at last it will be ending with the 1 year old. So after ending with 1, I can at the end I can get any number of 1s. right? So this is the basic structure. That means a continuous. After zeros, I am getting all the ones. So here Q naught contains 1, 0. It only contains a transition for the 0 here. What about the 1? So if I keep a 1 here as a loop, what it happens? It also execute a string called 101. 101. It reaches the final state. But this string is not accepted by my question because the string should starts with 0 and ends with the 1. But this particular question, it starts with 1. So even though this string is accepting this finite automata, so therefore here we should not keep the 1. So if I keep the 1 to the next state called Q1, what will happen? If I keep the next state 1, I can also able to execute a string called 11. I can also execute a string called 11. So is this 11 will be accepted my program? Oh, sorry, my question? No, because the string should starts with the 0. But here we are having 1. So therefore, this is also not accepted. So therefore, just I am simply sending it to the dead state. I am simply sending it to the dead state. So Q0 contains 0 and 1 over Q1 contains 1 and 0 and 1 over Q1. And what about the Q2? Q2 contains only 1 here. What about the 0? So if I get a 0 after any ones, is that a string will get accepted or not? So if I get a string called 0, 1, 0, 1. So look at here, even though it starts with 0, and ends with 1. Starts and ends with 1. So this string also will be accepted by my language. Right? So because the string starts with 0 and ends with 1 here. So that means after 1 also I should get a zeros. So I should not send it to the dead state. So I simply send it to the backtrack to the 0. So now check the 0101 string 0101. I starts with Q naught. On seeing 0, I reach Q1. On seeing 1, I reach Q2. On seeing 0, I reach again Q1. On seeing 1, I reaches the Q2. I starts from the Q naught as the initial state and I reaches the final state. Therefore, this particular string is get accepted. So here the entire it has followed all the DFA rules and it also accepts all the strings present in the language. So in order to check the particular DFA whether it is correct or wrong, we have to check by taking a correct string or by taking a wrong string. Your wrong string is nothing but the string which is not present in the language. So if I take a string called 101, is a string present in the language, or else if I take a string called 10, this 10 is not present in the language. So if I start with Q naught, on seeing 1, where I am going, I am simply going to the dead state, and on seeing 0, again I am going to the Q3. So initial state I move to the Q3. Is the Q3 is a final state? No, Q3 is not a final state. Therefore, this particular string will not get accepted by this finite automata. So this is a finite automata which accepts only a string starts with 0 and ends with 1. So is it clear? So this is how we need to draw the DFA. And some more examples are nothing but the next example that we are going here is construct a DFA which accept the strings A's and B's ends with ABB. So that means in the last question what we have taken starts with 0 and ends with 1. But in this question I am taking a string that ends with ABB. The string that ends with ABB. Before ABB, I can contains any number of A's and any number of B's. I can contains any length of the string, but it should ends with ABB. Right? So So in the same previous step by step process, first I need to find the input symbols which are given in the question. So what are the input symbols that they have given here? Sigma equals to A comma B, right? Sigma. In these are the input symbols based on the question. So what is the question? Which accept the string A's and B's? Combination of A's and B's ending with ABB. Ending with ABB. That means a language which contains ABB as a minimum length string. Next AABBB, right? BABBB, right? ABABB, right? Next AAABB, BBABB. So any length string you can take. That it should be ends with ABB. That it should be ends with ABB. So this is a infinite language. Right? As this is infinite language, what should we do? We should take the minimum length string. So what is a minimum length string in the language? The minimum length string in the language is ABB. So by using that minimum length string, we need to construct the basic structure of the deterministic finite automata. It starts with initial state. On seeing A, B, I reaches the final state. I reaches the final state. Right? So before ABB, I can contains any A's and B's. But as this is a DFA, it should contains only input symbol only once. So already it has seen A. Let me write Q0, Q1, Q2 and Q3. So it already seen the input symbol called A, right? So therefore it has only option of keeping the B here. So here B. And before ABB I can contains any length string, any number of B's. Right? After the A also I can contains any number of A's. Because if I contain a string called AABB, it will be get accepted. So if I want to, now Q0, Q1 is completed. What about Q2? Q2 has only a transitions on B. What about A? So if I get if I have an option like A, B, B, right? If I get after one B, if I get any A, this string also will be getting accepted. So here till I reach the B here. So if I seize the A, I just go back to this particular Q1. I just simply go back to the particular Q1. So therefore, if I seize any number of A's after 1B, I can end it with the ABB again. After seeing the A's after the 1B, I can end it with the any number of ABBs after seeing this A after the B. Right? So then after Q2 is also done. It also contains a input transitions for B1 and A1. Right? What about the Q3 here? So if I see the A here, or that means an input string contains AA, BB. After BB also, if I seize the A, I should end up again with the BB. So that means if I see the A again, I just reaches to this state called A. So therefore A, so A, B, B, A again it comes back. So again BB. That means it always, if I see the A, that it should ends with the BB. So right. So this particular string. So what it happens if I see A, BB. Till here I got. Sorry. After A, B, B. See A here. A, B, B. After this, what happens if I see on B? What happens if I see the B? That means after seeing B, no problem, but it has to end with the ABB, right? So where should I send? I should send it to the start state B. So therefore, even though if I see the B after the ABB, I goes to the start state. So I reaches the final state by seeing the ABB only. I reach as a final state by seeing ABB only. So therefore, this is the deterministic finite automata which ends with the ABB. This deterministic finite automata accepts the strings which ends with ABB only. So if I take an example like a string called AB, if I take a string called A, B, A, B, right? I starts with, even though it doesn't ends with ABB, it just ends with the AB. So let us check whether it will be accepted by this finite automata or not. Starting with the Q naught, on seeing A, Q naught on seeing A, where I'm moving? I'm moving to the Q1. Q1 on B, where I am moving? I am moving to Q2. Q2 on A, again I reaches to the state called Q1. Q1 on B, again I reaches the state called Q2. So is the Q2 is a final state? No, Q2 is not a final state. So therefore we can tell that particular string is not accepted by this finite automata. So if I take a string called A, B, B, A, B, B, right? So that means on seeing A, B, B, A, B, B. On seeing Q naught on A, it is moving to Q1. Q1 on B, it is moving to Q2. Q2 on B, it is moving to Q3. And Q3 on A, where it is moving, it is going Q3 on A, it is going to Q1. Q1 on B, it is going to Q2. Right? Q1 on B, it is going to Q2, and Q2 on B, it is going to Q3. So check it. I starts with the Q naught, which is an initial state, and reaches the Q3, which is a final state. So therefore, this particular string is get accepted by the deterministic finite automata. This is how we need to check whether the DFA that what we have drawn is correct or not. Okay, the next question that we are going to learn is construct the DFA which accepts the language the equals to W. We call it as a string length. String length mod 2 is equals to 0 over an input symbols 0 and 1. What is the meaning of this? First of all, let us learn the string length mod 2 is equals to 0. That means the meaning of this is when a string length is divided by 2, I should get a remainder 0. When a string length divided by 2, I should get a remainder 0. This one we can also able to write the string length is equals to is congruent to 0 mod 2. The string length congruent to 0 mod 2. That means when a string length is divided by 2, we call it the remainder is 0. So that means what are the string lengths that we divide? If I divided with 2, what are the string lengths that I will get the remainder 0? That means I will get a remainder 0 means when the string length is 0, I get the remainder 0. when the string length is 2, 0. When the string length is 2, I will get the remainder 0. When the string length is 4, I get the remainder 0. When the string length is 6, I get the remainder 0, and so on. That means when the string lengths are divisible by 2, all the multiples of 2, then the remainder will be 0. So based on these conditions, we need to draw the deterministic finite automata. So right, what is a language? So it's the string length divided by 2. So first we need to define the input symbols. What are the input symbols? Sigma is equals to 0, 1. And the language I have to write is, it accepts a 0 length string. When the 0 is divided by 2, the remainder will be 0. Right? So, I get the 0. That means how we represent the 0 in the language? We represent it by using the epsilon. And next, a 2 length string. What is 2 length string? If I take 0, 1, 0, 0, 0, 1, 1, 0, 1, 1 are the 2 length strings. And what is 4 length string? 1, 0, 1, 0, 1, 1, 1, 1, and so on. Same as 4 length string, 6 length strings, and so on. So as this language is an infinite language, what we have to take? We have to take the smallest string and get acceptance. So as how to make this epsilon accepted in the deterministic finite automata? In order to accept the epsilon, always makes the initial state as a final state. Always make the initial state as a final state. And let us see the 2 length string. In order to execute a 2 length string, what are the constraints that we will be having? It should contains 0 and reaches the 1 state, and if I see the 0 again, I reaches the final state. That means 0, 0 will get executed. Then what about the 4 length string? So here it is 1 length string, here it is 2 length string, it get accepted. And again if I move here, 3 length string and 4 length string will get accepted. If I move here, 5 length string and 6 length string will be getting accepted. So therefore, I can write the 2 input symbols on the same transitions. So 0 and 1, 0 and 1. So any length of the string that are the multiples of 2 length strings will be get executed by this deterministic finite automata. Q0 and Q1. Okay, clear? So, and one more thing that I have to mention you here, right? And one more thing that I have to mention in this here is, when a number is divisible by 2, we get 2 possibilities, right? 2 possible reminders, that is either 0 or 1. So 0 or 1. So that is the reason why this DFA, when divided by 2, we get only 2 states. We get only 2 states. So if in case, if a number is divided by 3, that means what are the possibilities that we get? We get a possibilities like 0, 1 and 2. We get possibility 0, 1 or 2. So therefore, how many number of states that we get here? We get 3 number of states. So based on this is small information regarding the number of states in the finite automata. Okay, so the next, if I see the same symbol, same question with the string length, if I divide it by 2, what are the possible string lengths? All the even length string lengths, right? But if I divide it by 2 and the remainder is 1, what are the string lengths? All the odd length strings. All the odd length strings. all the odd length strings. So, what is the question? Construct the DFA which accepts a language where string length divided by 2 is equals to string length mod 2 is equals to 1. That means a string is divided by 2. I get simply a remainder 1. Right? So that means what are the input symbols first of all? 0 and 1. And what is a language for this? I get starts with the odd length strings. Right? That means what are the string lengths accepted? 1, 3, 5, 7 and so on. 1, 3, 5, 7 and so on. Right? So if I divide it by what is a one length strings on the input symbol 0 and 1, I get 0 and 1. What is 3 length string? 0, 0, 0, 1, 1, 1, 0, 1, 0 and so on in the same way. Right? So is this a language finite or infinite? It is a infinite language. What if it is an infinite language? I should take the minimum length string and draw the basic structure of the finite automata. Starts with the start state Q0. I reaches by seeing 0 or 1. I reaches the final state. As I have told in the previous slide, if the number is divided by 2, we contains only 2 states. So here is one length string, it get accepted. Next, I also need to accept the 3 length string, 5 length string, 7 length string, next a 9 length string and so on. Right? So if I keep the loop here, what will happen? It also accept the 2 length string, 3 length string and so on. So loop should not be kept. So if I write here to the next state and if I not making this one as a finite state and sending it to the another state and making it as a final state. That means 1 length string accepted, 2 length not accepted, 3 length get accepted. So if I goes on drawing like this, it will be a very lengthy finite automata. So always we have to draw the minimized DFAs. Minimized DFAs. That means only a minimum number of states should be present in the finite automata. So here on seeing 0, 1, I reaches the final state which is of a string length 1. So if I goes back to the 0 and 1 to the Q0 with the string length 2. This is string length 1. This is string length 2. It will reaches the Q0. Q0 is not a final state. So it will not get accepted. On again, if I see the 0 and 1 and reaches the Q1 with the string length 3, it will get accepted. So here, this is a finite automata which will be get accepted all the odd number of strings, odd number of string lengths which are divided by 2 will be getting accepted here, odd length strings. Right? So let me check. If I take a string called 111, 1, 1, 1. This is a string length of 3. That is nothing but odd. That means it has to get accepted by this finite automata. On seeing Q0, I reaches the Q1. On Q1, on seeing 1 again, I reaches the Q0. On Q0, on seeing 1 again, I reaches the Q1. Here Q1 is a final state. I reaches the initial state to the final state. If I take a string length called 1010, it is a string length of 4 that it should not get accepted by this finite automata. On seeing Q0 on 1, it reaches Q1. Q1 on 0, it reaches Q0. Q0 on 1, it reaches Q1 and Q1 on 0, it reaches Q0. Where Q0 is not a final state, So even though I read all the strings, it does not ends up in the final state. So therefore, these strings which are of a even length string will not be get accepted by this finite automata. Okay, coming to the next question. Here, till now we have learned the string length divided by 2 with the remainder 0 and the string length divided by 2 with the remainder 1. Now we are going to learn the string length divided by 3 with the remainder 0. That means what are the possible string lengths that we will be getting? We will get 0, 3 length string, 6 length string, 9 length string and all multiples of 3. Right? So, first of all, input symbols are 0 and 1. And what will be the language here? Language is equals to divided by 3. Right? It accepts for 0 length string. That means epsilon 3 length string. 0, 0, 0, 0, 1, 0 and so on. 3 length string, 6 length string, 9 strings, so on. Based on these, this language is an infinite language. What we have to take? We have to take the minimum length string. Rather than the epsilon, we will take 000. Right? So I starts with the Q0. Right? I need to get accept this particular minimal state. Q0 on 0, it reaches the Q1. Q1 on 0, it reaches the Q2. Stop here. In the last slide, what I have told, when a number divided by 3, right, when a number divided by 3, it gets a remainder 0, 1 and 2. So therefore, it contains only 3 states. It contains only 3 states, right? Here already we kept the 3 states. So where I should keep the next 0? I should get it to the Q0. Right? As I have given in the language, I need to get accept the epsilon. Right? In order to get accepted the epsilon, I need to make the initial state as a final state. I need to make the initial state as a final state. So, my 3 length string get accepted here. Right? So, in the same way, 0, 1 is a combination of zeros and ones. Right? So, this is my string length divided by 3 equals to 0 DFA. So, any length string you can be taken on this particular DFA. On the multiples of 3, it will be get accepted. If I take any length strings which are not present in the language, it will be get rejected. So, if I take a string called 0011, if I take a string called 0011, Q0 on seeing 0, it reaches the Q1. Q1 on seeing 0, it reaches the Q2. Q2 on seeing 1, it reaches the Q0. Q0 on seeing 1, it reaches the Q1. Here Q1 is not a final state. So therefore the string length 4 is get rejected. In the same way, it will reject all the string lengths which are not present in the language. So next coming question is similar to this question only. The string length divided by 3, which leaves a remainder 1. The string length divided by 3, which leaves a remainder 1. So that means what are the possible language strings that we will get? 1, 4, 7, 10 and so on. 1, 4, 7, 10 and so on. So these are the string lengths that should be get accepted and all the other string lengths will be get rejected. So first input symbols 0 and 1 and the language is equals to first string length 1. That means it will get 0 accepted and 1 also will get accepted. And next directly 4 length string 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 1 and so on. It also accepts 7 length and so on. Right? Starting with the smallest string. As this language is an infinite language, I draw the finite automata. Q naught as an initial state. On seeing 0, I reaches the Q1. That means I need to get accept the final state. I need to get accept the string length 1. So I make the Q1 as a final state. Right? So if I get one more 0 here, what will happen? 0 and 1 I got accepted. What about the Q1? If I get a 2 length string 0 and 0, what it should be, what it has to do? It has to contains to the state which is not accepted. And it also should accept the 4 length string. That means it reject the 2 length string. If I send back a 0 and 1, it rejects the 2 length string. Right? And here if I take 0 and 1, here it accepts the 4 length string. And again it rejects the 5 length string here. 6 length string, again 7 length string will accept it. 8 length string, 9 length string, 10 length string. 10 length string will get accepted. So this will be execute all the strings which are divisible by 3 with the remainder 1. It will accept all the strings which are divisible by 3 and gets the remainder 1. So if I take a string called here 3 length string 0, 0, 1. Is a 0, 0 length string is present in the language? No, because it only accepts the string length 1, 4, 7, 10 and so on. It has to divide it by 3 and get the remainder 0. So here starts with the Q naught. On seeing 0, I reaches the Q1. Q1 on seeing 0, I reaches the Q2. Q2 on 1, I reaches the Q naught. Here Q naught and Q naught. Q naught is not a final state. So therefore this particular string does not get accepted. Right? So the similar question, what will happen if a string length divided by 3 is equal to remainder is 2? If I get a remainder 2, what will happen? Right? Here, if the string length divided by 3 and if I get a remainder 2, what are the string lengths that I will be get accepted? That is 2, 5, 8, 11 and so on. So here the input symbols are 0 and 1 and the language 2 length string. First it starts with the 2 length string 0, 0, 0, 1, 1, 0, 1, 1. 1 and next 5 length string 0, 0, 1, 1, 0 and so on. Likewise 8 length string, 11 string and so on. So here if I starts with Q naught and I take the smallest length string, I need to make it get accepted 0, 0, I reaches the final state Q2. I reaches the final state. Right? In the same way, if I get 1, 0, I reaches final state. If I get 1, 1, I reaches final state. If I get 0, 1, I reaches the final state. All the 2 length string is get accepted. So next, what length string I need to get accept? 5 length string. Where should I keep the Q2, 0 and 1? If I keep the Q2, 0 and 1 here 1 length string, 2 length string accepted. 3 length string does not accept, 4 length string does not accept and 5 length string will get accepted. Right? And 6 length string does not accept, 7 length string does not accept and 8 length string will get accepted again. So this is how these divided by 3 problems divided by 2 will be going on. So if the string length is divided by 2, how many number of states that we occur? 2 states. If the string length divided by 3, how many number of states that we will get? We will get 3 states. If the string length number divided by n, we will get n number of states. Okay. And the next question is, here this is a different question. On the finite automata, which contains a combinations of A's and B's, and it is giving a particular conditions only for the A's. That means in a finite automata, any length string, but it should contains exactly one A, at least one A. At least one A means one A and more than one A, and at most three A's means 0 A's, 1 A's, 2 A's and 3 A's, and at most 1 A means 0 A's and 1 A's. So first of all, let us construct the exactly 1 A. So here the input symbols are A comma B. First of all, for exactly 1 A, let me write down the language. Exactly 1 A means in the language it only accepts A, right? It accepts the A, AB, BA, ABB, ABBB, and so on. That means in that particular finite automata, it contains only one A. So I starts with the start state. On seeing a smallest string, right, I get accepted this particular string. Before A, I can contains any number of B's, and after A also I can contains any number of B's. Right? So here Q1, after A I should not, after QA I should not get any number of A's. If I take AA, I should get rejected. So that means if I get A, after A, on seeing after 1A, I see any A's, I should send it to the dead state. I just simply send it to the dead state. So if I take here example like AA, right? If I take an example like A, I starts with Q0. On seeing A, I reaches the Q1, and on seeing A again, I reaches the Q2, which is not a final state. So if I take a string length which is A, B, 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 A, B, B. So B, A, B, B. Starts with Q0. On seeing B, I stays on the same state called Q0. On seeing A, I reaches the Q1. On seeing B, I reaches the Q1, and on seeing B again, I reaches the Q1. Q1, which is a final state. So therefore, I reach the initial state to the final state. Therefore, this particular string got accepted by the finite automata. So whatever the string you can take, if it contains only single A, it will get accepted, right? Or else if it get rejected. Okay, the next one. And the next one is at least 1A. At least 1A. What is the meaning of that? The string length is 0. Sorry, the string length will be at least 1A, right? The string length will be 1 and more than 1. More than 1. That means the language is equals to A, AB, AAB, AA, ABB, and so on. Any length string it starts with, but in that string, any length string, it should contains at least 1A and more than A's, no problem. So I starts with the Q0. On seeing the A, I reaches the final state called Q1. So before A's, I can contains any number of A's and B's. So already here we have A, right? Simply I am keeping it as a B over there. So after A also, I can get any number of A's and B's. So if I take a string called AABB, here it contains 2 A's, right? On seeing Q0 on A, it reaches Q1. Q1 on A, it reaches Q1. Q1 on B, it reaches Q1, and Q1 on B, it reaches Q1, which reaches the initial state to the final state. So this is how we accept the string length at least 1A. Right? The next one is at most 3A's. At most 3A's means that the string length is equals to 0, 1, 2 and 3. The string length is restricted to 0, 1, 2 and 3. That means the number of A's in a string is equals to 0, 1, 2 and 3. So what will be the language here? Epsilon A, AA, 3A's, right? And A, B, BA, AAB, ABA and so on. Right? So in this, as this is a infinite language, I start with the Q0. But here, what is the restrictions? I should contains only 3A's. Right? Only maximum 3A's. If I start with the single A, I reaches the final state. On seeing second A, I reaches the final state. On seeing third A, I reaches the final state. So beyond this, I should not get any number of A's. That means if I get any number beyond this A, I just simply send it to the dead state. I just simply send it to the dead state. So then next, what about the B's here? So before A, I can get any number of B's. In between I can get any number of B's here. Right? So, but it should only contains the number of A's in this particular finite automata. So, as we also contains an epsilon, so in order to accept this epsilon, we are also making the Q0 as a final state. So, what will happen if I make the Q0 as a final state? It also execute a B, BB and so on. That means in B, BB, what it happens is a number of A's are zeros. Number of A's are zeros. So therefore, any length string which contains B's also will be get accepted here. So this is a at most 3A's. The next one is at most 1A. That means the string length of A should be 0 or 1. The 0 or 1. So what will be the language here? The language will be epsilon A or B. String length of 1 is also A or B. Right? Or AB, BB, BA and so on. Not more than 1A it should be get accepted. So I starts with the Q0 here. So here I can execute any number of B's, B, 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 3 B's or anything. So and also it should execute the epsilon. So I keep the initial state as a final state and writes the B. And here I need to execute a single A, right? Single A. And I reaches the final state Q1. And after A, I can contains any number of B's. But after 1A, if I see any A's, I just simply send it to the dead state. They just simply send it to the dead state. So this is the problems based on the exactly 1A, at least 1A, at most 3A's and at most 1A. Okay, the next type of questions that we are going to learn is when a string starts and ends with the same symbol. So if I have a input symbols called A, comma B, and the question is like when a string starts and ends with the same symbol, we have two options. Either the string can starts with either A or B, or a string can ends with A or B. So that means a different parts it is. So therefore, the what will be the language? Starts and ends with the same symbols, where A comma B is A and B are the input symbols. Right? So what is a language? Starts and ends with the same symbol. So I can take A itself, it starts with A, and itself it ends with the B. So I can take the A, single A. I can also take the single B. And I can take B, B. A, B, A. B, A, B. And so on. Any length string. As the language is infinite language, I start with the Q0. On seeing A, I reaches the final state Q1. And another one, on seeing B also, I should reaches the final state Q2. What about the string length 2? If I give the string length to the backward direction to the A, that means in order to get accept AA, is it getting accepted there? No, it is not getting accepted. That means, so therefore I am just simply giving the loop here. A and any number of A's starts and ends with the same symbol. Here also B and any number of B starts with B and ends with the B. So here Q0 contains A and B. What about Q1? Q1 contains only A. What about B? If I give the backward B here, what will happen? It will execute a string called A, B, B. It can execute a string called A, B, B. See here. Q0 on A, it reaches the Q1. Q1 on B, it reaches Q0. Q0 on B, it reaches Q2. Q2 is a final state. So this string is accepted. So, but what is my question? Starts and ends with the same symbol. So, therefore, we should not send the B to the back direction. So, where I should send? I just simply take the separate straight B and I will be giving it here. Right? AB. So, AB. After AB, I should get again A in order to make the acceptance. So, here A where I should send? I just simply sending it to the backtrack A. So, here after A, B, B, A. In between A, I can get any number of B's. I can get any number of B's. In the same way here, if I need to execute a string called A, B, I should give here A and Q4. Any number of A's I can get. If I should end again with the B. So this is how the starts and ends with the same symbol. Okay, the similar question here, what is a question? Starts and ends with the same symbol. And the next question is starts and ends with the different symbol. Right? Starts and ends with the different symbol. So here, what are the possibilities? The language equals to, if I starts with A, it should ends with the B. If I starts with B, it should ends with the A. If I starts with A, in between I can contains any number of things, but it should ends with the B, and so on. Any length string we can take, 2 length string, 3 length string, whatever it might be, but it should starts with A and ends with the different symbol. So on taking the smallest string here, on seeing Q0 on A, it reaches the Q1. Q1 on B, it reaches the final state. Right? In the same way, if I starts with the B and reaches the Q3, and on seeing A, I reaches the Q4, and the Q4 will be a final state. Right? Here we have accepted only 2 length string. What about 3 length string, 4 length string, 5 length string, so on. right? So in between A and B, I can contains any number of A's and B's, but Q1 contains already B. So therefore, I can keep the A here, right? But here next one, if I contains a Q2 here, Q2 can ends with the any number of B's, but if it get any A's, it has to be go back to the Q1 and always ends with the B only. Always it should ends with the B. In the similar, in between B and A, I can contains any number of B's or A's, but already Q3 contains A. So I can contains any number of B's here. Q4, it has to ends with A. So I can contains any number of A's here. So if Q4, if it wants to seize the B, it has to go back to the Q3, and it also should ends with the B A again. So therefore, this is the deterministic finite automata which accept the string starts and ends with the different symbol. So if I take an example called A B A B A B A B, Q naught, on seeing Q naught on A, it reaches Q1. Q1 on B, it reaches Q2. Q2 on A, it reaches Q1, and Q1 on B, it reaches Q2, which is a final state. So if I take a string called AA, BA, starting with the Q naught, on seeing A, I reaches Q1. Q1 on A, I stayed on the same state Q1, right? Q1 on B, I reaches the Q2. And Q2 on A, I reaches the state called Q1, which is not a final state. So the string is not accepted. So this is all about your problems on the deterministic finite automata. So you can take many number of examples. So these are the basic type of questions that we will be come across. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.